Okay, so moving on. Again, we're given another differential equation, dy over dx minus xy is equal to x, if the initial value being equal to 5 at 0. So then we use the same logic. We need to get it in this form, dy over dx plus p of x times y is equal to q of x. So let's just rewrite it here so we can refer back to it. Plus p of x, y is equal to q of x. Now, obviously, you can see that we more or less already have the form, right? We have our equation is already in that form, meaning that simply simplifies our job because our p of x then is just negative x, right? And our q of x is x. Okay, and that just means that our mu is e to the integral of p of x dx, which is just e to the integral of minus x dx, which is e to the minus x squared over 2, which is, yeah, we can just leave it like that. Then y is therefore equal to 1 over mu, which is 1 over e to the negative x squared over 2, multiplied by the integral of e to the negative x squared over 2 times q, which is x dx. All right. So, okay. So here, at this point here, we can use our, well, we can rewrite this first as e to the x squared over 2 times the integral of e to the negative x squared over 2 times x dx. Now, this integral here can be solved by using our u substitution. And in this case, we'll just let u be equal to, and at this point of the video, you are more than free to just pause the video for a few minutes and think about what you could substitute u with, okay? So think about it for a few minutes and then obviously pause the video and then just press play and find out. So for our case, we'll let u be equal to negative x squared over 2. And that would just mean that our du is equal to negative x dx. And therefore, the integral of e to the negative x squared over 2 x dx is just equal to the integral of e to the u times minus du, which is equal to the integral of e to the u du, which is equal to, there's a negative there, which is equal to minus e to the u. Minus e to the u plus our constant of integration, obviously, c. Now, u is negative x squared over 2, so that's just then minus e to the minus x squared over 2 plus c. And so, what does that mean? Well, it means that our y is equal to e to the x squared over 2 multiplied by what we found from our integration, which is negative e to the negative x squared over 2 plus c. And we know from the initial value that y of 0 is equal to 5, which means that e to the 0 times negative e to the 0 plus c is equal to 5. Meaning that minus 1 plus c is equal to 5. Meaning that c is equal to 6. And what does that mean? Well, it means that our y is therefore equal to, if we substitute the value of c, e to the x squared over 2 multiplied into e to the negative x squared over 2 plus 6, which if you multiply in the factor outside here, you have minus 1, because remember, e to the x squared over 2 times e to the negative x squared over 2 is just e to the 0, which is 1, plus 6 e to the x squared over 2, which is our final solution. Right, so moving on from integration differential equations, we are moving on to sequences now. Sequences, we are introducing the concept of sequences and convergence of these sequences and series. So this is a concept that's quite important as well for mathematics. So you will find as we move along and as we explore different types of problems that there are multiple ways to solve, multiple methods to solve for the convergence of to basically investigate the convergence of a specific series or sequence. And it's all about knowing which one applies for a specific problem, right? So this question here that we have is giving us a sequence, right? Which is root n over roots of n plus 1 plus root of n, going from n is equal to 1 to infinity. So that series or that sequence. And they are asking us if it's convergent, right? Well, how do we do that? How do we know? Well, we take the limits, right? We have to investigate what happens when n tends to infinity. So as n increases from the value of 1 to an increasingly higher and higher value, what happens to the sequence? Well, if the limit as n tends to infinity of root of n over root of n plus 1 plus root of n, well, we know that that's just equal to what? Well, we know that in these cases, for these limits, we just divide by the highest order, both in the numerator and denominator. So our highest order here is just a root of n, so we have limit as n tends to infinity of root of n over root of n all over root of n plus 1 divided by root of n plus root of n divided by root of n, which is equal to the limit as n tends to infinity of 1 over root of n plus 1 divided by n is just 1 plus 1 over n under the square root plus 1. Now, what happens if you substitute infinity into this? Well, we have that this limit is equal to 1 over root of 1 plus 1 over infinity, which is 0, plus 1, which is equal to 1 over 2, which is our final answer. So, what does that mean? Well, it means that as n tends to infinity, the sequence converges to 1 over 2, right? So that means that the sequence converges because the limit exists. Okay, so that's done. Moving on to the next question, which is also another sequence. And now for these sequences, we are asked to investigate whether they are strictly increasing or strictly decreasing using the differentiation, right? So how do you do that? Well, using differentiation, we know that, what do we know? Well, we know that if we let the sequence that's given to us here, which is n times e to the negative 2n, if we let that be equal to our f of n, right, function in terms of n, now the derivative of f in terms of n, which is f prime of n, is equal to what? Using a product rule, you have the derivative of n, which is 1, times e to the negative 2n, plus n times the derivative of e to the negative 2n, which is negative 2, times e to the negative 2n. And that's just e to the negative 2n minus 2n times e to the negative 2n, which is just e to the negative 2n multiplied into 1 minus 2n, which is the same as 1 minus 2n over e to the 2n, which we can clearly see as n increases, right? This is less than 0. It's less than 0 for all the values of n going from, starting from n is equal to 1. So what does that mean? Well, it means that our sequence, right? So that means that the sequence is strictly decreasing because the first derivative of the function is less than 0. Right? So the sequence is strictly decreasing. So that's our conclusion. Now, moving on to the next question, which is ln of n plus 4 over n plus 4. And we are asked to investigate again if this sequence is strictly increasing or decreasing using differentiation. So once again, let this be equal to f of n. Then df of dn is, which is equal to f prime of n, is just equal to the derivative of, use the quotient rule, derivative of the numerator, which is 1 over n plus 4, multiplied by the denominator, n plus 4, minus the numerator, ln of n plus 4, times the derivative of the denominator, which is 1, all over the denominator squared, so n plus 4 squared. That is just equal to what? As we simplify, 1 minus ln of n plus 4 all over n plus 4 squared. And as we can see, this is also decreasing. Well, rather it's less than 0 as n increases. That means that, once again, this sequence as well is strictly decreasing. And how do we know that? Well, because the numerator is negative and the denominator will always be positive. So you're dividing a negative number by a positive number, and what you get is a negative value, which is less than 0, which means that the sequence is strictly decreasing. Okay, so that's that. Moving on to the next question, which is giving us a sum, right? So a series, and we are asked to find, or rather to show that the sum, right, as k goes from 1 to infinity, of 1 over k minus 1 over k plus 2 is equal to 3 over 2. Well, how do we do that? Well, we know that the sum of this series just means that you take the first term, which is just when k is equal to 1, 1 minus 1 over 3, plus the second term, which is when k is equal to 2, 1 over 2 minus 1 over 4, plus the third term, k is equal to 3, 1 over 3 minus 1 over 5, and so on. Right? All the way until, let's say, you get to the nth term, right? So the nth term will be wherever you stop in the sum of the series, right? And if you look at the term before that nth term, which will be the n minus 1 term, right? If you think about it. So you look at the n minus 2 term, then n minus 1, and the last term, which is n, you will find that it's equal to 1 over n minus 2, right? Which is the n minus 2th term, right? Minus 1 over n minus 2 plus 2, which is 1 over n, plus the second to last term, which is n minus 1, minus 1 over n plus 1, plus 1 over n, which is the last term, minus 1 over n plus 2. Right? So now if you sum up all these terms, you can clearly see that 1 over 3 will cancel with that 1 over 3 there, right? 1 over 4 will also cancel with the term that just comes right after the fourth term, okay? Which, if you were to continue, will be 1 over 4 minus 1 over 6, right? So 1 over 4 will be cancelled as well. And immediately you know that 1 over 5 will be cancelled too, right? But 1 and 1 over 2 will be left. And if you continue doing that along the way, right, you will see that of all the terms that will remain, right, all the other terms will be cancelled, right, obviously. And the only term that will remain will be what? Well, if you think about it, the only terms that will remain, right, sorry, I'm supposed to do this one. So the only term that will remain will be this one, right? Will be obviously 1 first here, 1 over 2, 1 over n plus 1, right? This term will be cancelled with the term, the two terms before, right? So this one will be cancelled. Same with this, which was cancelled with that. This one as well, the two terms before that. And this will be left as well. So the sum will therefore be 1 plus 1 over 2 minus 1 over n plus 1 minus 1 over n plus 2. Right? So that is what our sum would look like. Now, if you go even further, higher than n, closer to infinity, which is what we have there, what happens as n tends to infinity, right? As n increases and increases again, you'll see that this term will get closer and closer to 0. Same with that term as well, closer and closer to 0. And what does that mean? Well, it means that you'll be left with 1 plus 1 plus 1 over 2, which is 3 over 2. So this series or sequence will converge, right, to a value of 3 over 2, right, as we were asked to prove. So that is the final answer there. All right. So I think that's all the problems. And thank you for joining me for today's session. And yeah, I'll talk to you in the next one. Thanks. Bye.